look at interactions between positive and negative charges. So a key idea with this is that oppositely charged objects or opposite charges will attract. There's something that pulls them together. And then like charges repel. So if you get a positive and negatively charged thing together, they're going to be pulled toward each other. If you get two positives together or two negatives together, they actually push apart. So one way I can actually set up a positive and negative material is with tape. So like Scotch tape or clear tape. I've got a piece stuck to the desk here, and I'm going to take a second piece and kind of just fold the top to make a little handle so that I can pull it off in a moment. And I'm going to put that right on top of the other piece of tape, kind of smooth it down, and I'm going to label it with a B for bottom, because I'm going to make another piece of tape like that called the top piece. That'll be T. That's a bit too much. There we go. And it's a little bit longer than I wanted. Fold it again. So it's going to go right on top, and I'm going to label that as T for top. So there's a way to make an electron transfer occur between these two pieces of tape. And the way you do it is you take both pieces off, kind of quickly take them off, so that piece stays down. You touch the top tape, and then you tear them apart quickly. And there's something about that process that actually makes an electron transfer happen. And one of these tapes is going to be positively charged, and the other is going to be negatively charged. So these have opposite charge. They should attract if I bring them together. Okay, see how when I got them close enough, kind of pull together, okay? So I'm not sure yet which one is positive and which one is negative. We're going to do some observations to catch that. So this is the bottom tape. So I've got that by B. This is my top tape by T. I will say these electrostatic demonstrations work best when the air is very dry. And because it's rainy outside today, it's kind of humid in here. So I will probably leave these materials out, and we'll probably look at them again once the heat gets running and the air gets dried out in here. But what I want to do is try to determine whether the B tape or the T tape is positive or negative. So they mentioned in the video how if it's dry in your house and you walk around on your house, you can actually transfer electrons to your carpet. So if you get rid of negative electrons, you become positively charged. And that's actually true of a lot of different materials. Just by kind of rubbing them together, you can get an electron transfer. Another really good material for that, or two materials actually, is fur and plastics, okay? So this is just PVC pipe, a type of plastic, and I can actually rub electrons onto the PVC pipe with the fur. And you might even hear like some staticky crackling happening if you listen. So I'm actually rubbing electrons from the fur onto the pipe, and the pipe is going to then be negatively charged, okay? So I want to see how this interacts with the T tape and the B tape to figure out which is which. So if I bring it towards the T tape, can you see it attracting? Opposites attract. This is negative. It's hinting to me that the T tape must be positive. I want to jot that down. So the T tape is looking to have a positive charge, which would suggest that the B tape is negative. Again, the PVC pipe becomes negative. If I bring those together, you see how it's repelling a little bit? That's quite a bit actually. So they're not touching, but there's enough negative charge here and on the tape to make them repel. Okay. So I've got evidence that the B tape is negative. So hopefully, by seeing that, it's a real thing, right? When we talk about, say, electrons being negative and the nucleus being positive, we know there's actually an attraction there between them. The electrons would probably just go flying off in space if they didn't have something that kept them kind of attracted to the atom itself, to the positive core and the protons. So I want to do another thing. I was able to make a negative object with the PVC pipe. I want to make a positively charged object and see if we get the same sort of evidence from the T tape and the B tape, right? So I've got a couple of things. So I actually ordered this device, and this is a device that allows you to charge up a piece of metal positively, and I'll explain kind of how we do that in a second. The interesting thing was, I ordered this from a science supply company, and I'm trying it today, and the one that I've used for years, which is very low tech, actually works better. So this is just a pie pan with a cup taped to it. The reason I have the cup taped to it is the cup is plastic. It's not a good conductor, meaning electrons do not flow through it very easily. And I want to be able to pick this up without actually touching the pan. So let me explain how I can charge up the pie pan so that it is positively charged. And then we'll do a couple interesting things with that too. This is just so you can see it a little better. And again, this is like a $2 demonstration, right? You can make this stuff, find it in a grocery store. But I'm going to take a styrofoam plate. Styrofoam is a type of plastic. So like the PVC pipe, I can get it to pick up some negative electrons. And if I put the plate on here, you don't see it, but what happens is the styrofoam plate is negative. And because the pie tin is metallic, it has some electrons that can flow, that can move from atom to atom. And so if I make the base very negative, the electrons that can flow are actually pushed upward in the pie pan. So it's not visible, but you would actually have kind of an excess of electrons around the top of this pie pan, and then less electrons near the bottom. And so there are electrons here at the top that would love to get even further away from the pie pan. I can actually give them a path to do that by touching it. And we may hear a little bit of a snap, like a shock. But again, it's kind of humid in here today, so it may not be great. I could hear it, you probably couldn't. And notice what happens then when I try to pick it up. There's an attraction there now between the pie plate and the negative styrofoam plate, because this has now become positively charged, because when I touched it, some of the electrons jumped off, flowed through me to the ground, and now it has lost some electrons. So if it loses some of its negative material, it's now positive, okay? I can also get electrons to jump back to the pie plate if I go to something else metallic that has some electrons that can flow. So we may hear this one a little bit better. Did you hear it? Yeah. It's pretty soft. It's not a super strong shock. If it's dry in here, you can even see the little blue spark jump between the two metal surfaces. So what's actually happening, this becomes positive, and it's able to pull some electrons from this post, and then it neutralizes its charge again. So notice now it's not picking up the plate. I have to charge it up first to do that. I probably need to do this again. Get the styrofoam plate negative, discharge it, and now they cling together. Oh, even more so. That one is actually quite good. So another way I can demonstrate that is actually with a compact fluorescent bulb. these are very energy efficient. You don't need a lot of current flowing through them to make them light. Obviously, to keep it lit up, I would need a constant flow of electricity through the light. But I want to turn off the overhead lights and the screen. And we should be able to see evidence again that there's an electron flow happening. Because electricity, all electricity is a flow of electrons through some sort of conductor, usually some metallic wire or something like that. So let me get everything where I want it. Turn the screen off too. Get the pi plate charged up negatively again. Electrons are forced up. I discharge them by touching it. Now the pi tin is positively charged. And I'll bring it over to the light bulb. You see it flash just a really, really quick instant in time. As it discharged, there was some electron flow, enough to actually light the bulb for just a moment. And again, this works a lot better if it's dry in the room. But there is enough electron flow there, electricity, that makes it light for just a moment. So again, just think about why electrons do this. It's really two things. Their negative charge allows them to be pushed and pulled around by other charged things. And the fact that they're very lightweight, right? They have almost no mass, makes them very easy to kind of push around using different charge, either pulling towards a positive charge or pushing away from a negative charge. All right, one other thing I want to show you. So I'm going to go back to the PVC pipe again because it really gets charged up quite well. And what I want to do is get the PVC pipe charged up and bring it close to this Diet Coke can. So again, if I were to bring something negative towards this side of the can, the electrons that are loosely held in the can would actually flow away from that negative thing. So the far side of the can is going to get partially negatively charged, and the near side is going to be partially positive. So if I bring the PVC pipe here, and it's negative, and it induces this charge so that the near side is positive, there should be an attraction there, because you've got a negatively charged thing close to a positively charged thing. I'm going to get this charged up. And you hear it crackling as it gets electrons transferred to it. And so I can actually use that attraction to roll the can from a distance. Again, the idea is I'm inducing a charge in the can, making the near side positively charged, and then it's going to be attracted and pulled towards the PVC plate. I forgot, there's one other thing I wanted to check. I wanted to prove that the pie pan was positively charged with the B and T tape. So let me do that too. Really feel that one. So positively charged next to the T-tape. It does in fact repel. We said the T-tape was positive. Positive interaction is a repel. And then I should see some attraction with the B-tape. It's not super strong, but when I get it close, it does pull over. So again, probably over time, the positive and negative charge on the tapes are going to discharge through the air very slowly. All right. So hopefully that just makes something that seems very abstract a little bit more understandable. This positive and negative charge interaction is something that's really, really crucial in chemistry. Stop that.